Hey everyone, Paul Daniels here again, and another daily fix. This time we're doing some programming. This is going to be for the benchtop multimeter that I received yesterday. That's the Vici VC8145, which I've already seen plenty of people trashing, and yeah, I mean, I totally understand. It's definitely not a world-leading class multimeter or anything like that, but it's cheap and it will probably do the job pretty well as we need. I mean, all we're doing is cracking walnuts, so I don't think we need a titanium forged with maple handle carbon fiber reinforced hammer to break open these walnuts. We just need a rock, and that's what we've got. So don't get me wrong, I'll happily take myself a nice 344 series or some $1,000 multimeter and I'll put that on my bench and I will use that, but there are other things that are more important right now to spend the money on, and this meter is going to do the job just fine. So I've got myself a specification sheet. This here details the protocol that the meter talks, and I've already earlier today put together a bit of code that at least lets me see the data coming out, and now it's a case of I'm just going to flesh it out some more, and then hopefully by the end of this session we can have a proper STL graphic interface showing up ready to be used into Openbroadcaster. So let's get on with it. Better take a sip of coffee first. Oh, where's that last sip? If you don't get that last sip, it drives you mad and you have to go and get yourself another coffee. Alright, let's get on with the code. So at this point, let's see, we had to change a lot of things because remember, this is a query type meter, it's not just a blind broadcaster. Let's see, where were we? Alright, one of the first functions that I tested is you send a hex code 89 to the multimeter, and then it will return back what's on display along with the status. So let's see. I know it's strange, but I do prefer to have specifications out on paper like this. It just makes it easier to deal with going back and forth. When you're coding, it's nice to having it printed out is kind of like having another screen with your document permanently on it. So you know, just stick this off to one side somewhere and it's ready for you to look at anytime you want. Alright, so we send the 89 command to it, and then it's going to send back 12 bytes, and at the end of it we should get a OA or a code 10, and that should indicate the end of the frame. We then go along and, like with all the other meters that we have, we check to see that the frame size is what we were expecting. And let's see, we've got the meter on. We're going to put it onto the temperature mode. Actually no, we'll leave it on, what are we on now? DC volts mode. So we'll run this. Oh no, you see my password. Alright, so we can see we're getting data back. I've actually slowed this down. You will notice there's a couple of things here. Invalid number of bytes. We're looking for 12 and we've got 11. And what's interesting is the data itself is really different. These two we can ignore. As far as I understand, this here is all the screen. If you subtract the 30 from the value, you get what's on the screen, so it would be 0004, which does replicate pretty much what's on screen here. So let's see. There you can see 3, 4, 4, 3. So I'm not sure why every now and then we have this frame that comes through that's just BFBFDD. I'm not sure. Anyway, so we just discard those and ignore them, and we load up the previous frame of data. I don't even know if we need to worry about that because we have so many frames coming in per second. Yeah, we'll drop it back to 1/10 of a second for now. That way we're not thrashing the system too much. By the system, I mean the actual computer that it's on. Alright. So that's the display data. So what can we do? Alright, let's work on that. Now what we're going to have to do is, depending on what command we've sent, our frame sizes are going to be different, because there's another command which will give us the analog bar, and that's a 9-byte response. And there's another command that will give us the device state, and that's only a 3-byte mode, and that gives us our modes like volts AC, volts DC, things like that. For now we'll stick on, we're after command 89, which isn't going to really show up there, but yeah, command 89 is what we're working on. Actually, I just realised that does give us device mode in that. Then why do we care about device state? Oh, I realise. Okay, what I'm talking about here is there's these first 3 bytes here that it gives the breakdown on. I thought that was a separate command to bring that up, but it's not. That is actually an expansion of the leading bytes that you get from the frame when you query it for the state. Alright, excellent. We're on our way. So we'll probably only ever use the command 89. I can't imagine bothering with a barcode in this case. Okay. Let's get the digits up first. Well, the fun thing is I have to work around my existing code. We don't need this anymore. I had that continue statement there simply so that it would keep looping around while I was getting the initial data coming up. So now we're going to start actually decoding this data. Alright, so all this D16, 17, 18 stuff, that's all got to change. Oh, I really hate this. It's always different. Every single meter seems to do things differently, so you don't get to recycle your data to your code much. So let's see, in our first byte, bits 3 to 6 represent our mode. But I'm not sure that's kind of... Alright, but so we'll mask that. Okay. So we'll go switch D. Right, D1. And we mask it, so if we want 3, oh, this is how you cheat. Rather than trying to work out the values in your head, you just go mask. Oh. Here we go. It's so wrong. I should know that. So what is that? That's 8, 6, 8 in hex. Well, the values are all in weird order, but I'm just reading it straight off the sheet, like that. No focus. There we go. Yeah, just read them straight off the sheet like that. Let's see, we want our units. Where are our units being held? Now the question is, are the units just something we set? Unfortunately the data here isn't exactly, the data sheet is not fully comprehensive. We'll just comment out all this code. As we don't know where the decimal point is. Yeah, I love when specifications don't really detail even things like that. Guess we'll just have to deduce that. Simplified version.
Oops.
At this stage we might be able to get our first screen done. We've probably got bugs that we've got to fix first though. Compile bugs, that is. Yep. mode was not declared in the scope. Fantastic. Alright, well in that case we'll just leave this out for the moment. I'm not getting any display. That's not a good start. Why not? Oh, I know why. Because that function does not match. Alright, well we've got some success there. Let's see. Too many. Yep, so that's working. Now we just got to work out our decimal places and the fact that I've got a leading negative there. Alright. Alright, so the leading negative, that will be a sign bit. Interesting. According to this, they have 3 bits set to the sign. That's interesting. Also, it looks like we're going to have a special decoding of the sign character as well. Interesting, it has an option there for unsigned value. So I guess we'll just consider unsigned and positive at this stage to be the same. So switch, let's say D4 and cheating again. Fancy that. So 0 case 4. Realistically, I probably could have actually just done case 5 only and then have everything else as a default. Oh well. Especially when up here I can just set the default to a space. Now we do have a leading negative here, minus, and that's not showing up. Alright, so byte 4, which is this one here. It's got 50, which would imply that yeah, 5 would be bits 6 and 4. Honestly, these specifications, if you're going to write specifications, well, I guess I'll be updating these. Might change to another mode and see if we can bring up, well, obviously ohms as, let's see, my goodness, that's loud. Okay, we got diode mode, and that should, okay, diode mode gives 40. 50 is negative. Oh, I think I know what's going on here. Yep, specifications for you. Right. So this should be 3.1000 something volts. Okay, so we've got a decimal place at the second position. Now, according to the spec, our range is in bytes, byte 4, bits 2 and 3. So that's the upper half of the nibble. Same as the sign. And that's all 0. What I'm going to do is change the volts mode and then forcibly change the range. And what I'm also going to do is slow down the update rate to once a second, and that way I don't get excess data flowing through. Okay, so we've got nice, so we've got 0 volts, and we've got 2 decimal places here. 3, 4, 1. Okay. Now to have a look at that sequence. I might drop this bit out. We'll stop messing with our visuals. Okay. Biggest thing I can see here is this column 80, 88, 90, 98. That looks like in there, that byte 2 of the device mode, but it's probably always been there. And lo and behold, it is. Byte 2 of device mode is range. Okay. Just going to shift this over to the other window so I can look at this while I'm so D2 mask let's see 838 and what are we looking for? So I'm pretty sure we started out with at the 1 decimal place at the first. Alright. I think I can get that. And I'm fairly sure our next one should be 90, 88. Whoops, my bad. 88. Where is it? 889098. Alright. Did I recompile that? Yeah, I did. Ah, idiot. The mask was wrong. I was masking the byte, but I wasn't compensating for that. I wasn't reflecting that in the comparison. And I'm still not. What's going on here? Interesting, got a 15 byte sequence there. Of course. No, alright. There, that's better. Let's try range. No, that one didn't quite go. Oh yeah, there we go. Yep. And no more. Alright, that's good. So that's the range. And we broke things. Marvelous. Okay, what's next? Units. Units. I gotta get the destruction manual. What I'm looking for in this is to see if rather they have the mu character, that micro. Because if they do, then somehow I have to find that in the... Yeah, they definitely do. Alright, that's gonna be fun. There you can see there that the mu character is definitely there. Because that would be microfarad capacitance. Can't imagine being anything else. I don't think we're going to have a microvolts display. I think it'll be millivolts, and that'll be it. Yeah, I think that's how they're getting away with this. Alright. We're going to do the coarse representation. Where do we do that? Up here. Okay. M mode is meter mode. Certainly with the ohms mode, we should be dealing with K ohm, mega ohm, and that is not represented. It's not represented in this section. So this is more the actual meter mode it's in. It's not in the units mode. That mega ohms, kilo ohms. So we're just gonna have to. I'm gonna have to get my meter leads and do that empirically. So I've got my nice alligator clips. I'm gonna plug these in. And I've got a box of axial resistors. I very, very rarely use these. So a lot of this stuff's well over a decade old. I'm trying to find something around about the 100k mark. 150, yeah, a lot of these are very low ohm resistors. 2 ohm to 1 ohms, sort of, yeah. 12 ohms. Looks like I didn't believe in large values. What do we got? We got 10k. I suppose I could, oh yeah, of course, I can just force it through the range selector again. Alright. So we got a 10k. And it's not bad, these are 1% resistors. So something went wrong there. Oh, they're so noisy. And that decimal place is out of place. Why? So that should be reading kilo ohms. So range. Okay, we've got mega ohms there. I'm just going to stop that. Because we switched over to mega ohms at some point. Okay, I've got a feeling it might be this here. Because all... okay, so A naught, that's 1, 0. So it'll be the 8 and the 2. Something else different here. Or we might have to do a resistance specific interpretation of the range triplet. So for resistance, on ohms mode, that's this one here. OC. I suppose I could make this code more portable for future situations if I actually interpret all these and then set the state to my own version of the, just my own internal codes, and then from the internal codes I then set all this here. But I'm not going to do that. We want to see if, let's see, bit 5 is set. Kind of cheap with that, like that. Not sure why I've got triple in there, but I could have just searched replace, but I wasn't quite sure what I was doing with there. Not sure what's going on here. It seems to get started and stops. Very annoying. Very loud. So under normal circumstances it should be kilo ohms. Here comes the mega ohms. But it's not giving me that. Folks, where's my data? There we go. Well, that's fun. I don't even have a... I've got nothing at the end of there. Oops, someone left off something. So character, and then pair. Oh no, that's right. Because there's not going to be a decimal place after the final digit. This should break a lot of stuff. Hopefully I remember to remove that ×2. Alright, so for some reason we're getting nothing on our my head's a little low there. I need a wider angle. Oh well. Do you have anything that we've got nothing in the lead either? Definitely not what I'm expecting. So this is in ohms mode, and my mode sequence is E0. So if you, it's just, if you go volts DC, it breaks everything. Nice. For some reason the meter is not sending out the data after I received the first byte. These are all wrong. Everything's wrong here. I really don't know what goes wrong there. That's gonna suck something serious.